Hello, and welcome to another video of tutoring with Leah Cremona.
It is time to convert moles to grams. So in this case, the number of moles will be given, and you will have to find the number of grams in that given number of moles. Like in the conversions from grams to moles, you need to know the chemical formula, and you need to find the molar mass. And only then can you find the number of grams. In this case, you will use this equation. The number of grams is equal to the moles that were given in the question multiplied by the molar mass. So as you can see, for these grams to moles conversions and moles to grams conversions, you need to be very comfortable with finding the molar mass of compounds. Alright, so example 1. How many grams are in 1 mole of sodium fluoride? Alright, so the first step is to find the chemical formula for sodium fluoride. Sodium is represented by Na and has a positive 1 charge. Fluorine is represented by F and has a negative 1 charge. As in previous examples, the entire charge of the compound must equal 0. So if we add 1 sodium and 1 fluorine together, we have 1 minus 1, which is 0. So we know that we have this as our chemical formula for sodium fluoride. The next step is to find the molar mass. Sodium has a mass number of 22.99, and fluorine has a mass number of 19. We do not need to multiply these numbers by anything because there is only 1 of each. So now we add these two together. This gives 41.99. This here is the molar mass of sodium fluoride. Now the next step is to find the number of grams. And we know that the number of grams is equal to the moles that were given multiplied by the molar mass. So now we just plug in the numbers. The moles that were given for this question were 1 mole. So 1 times the molar mass. The molar mass is 41.99. And here was just 1 mole, we know that moles can cancel out, giving us the answer in grams, 41.99 grams. Example 2. If there are 2.5 moles of vanadium 3 oxide, how many grams is this? The first step is to find the chemical formula for vanadium oxide. When we look at the periodic table, we see that vanadium is represented by V and oxygen, is represented by O. So we have vanadium and we have oxygen. Now, from here, we know that the Roman numeral is telling us that vanadium in this example has a positive 3 charge. And we know from the periodic table that oxygen has an ionic charge of -2. We need the compound's charge in total to equal 0. So in this case, if we just added 1 vanadium and 1 oxygen, we would have the charge of +3 minus 2, which we know is +1, which is not 0. So this cannot be. So we need to figure out how many of each vanadium and oxygen we need in order to have a neutral compound. So finding the common factor between them, we can see that here, if we have 2 vanadiums and 3 oxygens, you will have a neutral compound. So picking 6 as a common factor, to get to 6, 3 must be multiplied by 2, and 2 must be multiplied by 3 to equal 6. So now, when we recheck the charges, if we have 2 positive 3's, so 2 times 3, which is 6, plus 3 times -2, which is -6. 6 minus 6 is 0, which is the correct formula for vanadium 3 oxide. Now, after finding the chemical formula, we need to find the molar mass. So vanadium has a mass number of 50.94 grams per mole. However, we see that we have 2 atoms of vanadium, so we must multiply this number by 2 to give us this. Now for oxygen, we know that we have 16 grams per mole, but we have 3 atoms of oxygen, so we must multiply 16 times 3 to give us this. Now we calculate. 50.94 times 2 is 101.88, and 16 times 3 is 48, and the units are in grams per mole. Now, to find the molar mass, we add these two numbers up. So the molar mass here is 149.88 grams per mole. Now we can calculate the number of grams. So we know that the number of grams is equal to the given number of moles multiplied by the molar mass. Plugging in the numbers, the given number of moles was 2.5 moles. And we multiply that by the molar mass, which is 149.88. .5 times 149.88 is 374.7 grams, which is our answer. So we know that there are 374.7 grams in 2.5 moles of vanadium-3 oxide. Example 3. If there are 50 moles of carbon dioxide, how many grams is this? So in other words, how many grams are in 50 moles of carbon dioxide? The first step is to find the chemical formula for carbon dioxide. Carbon is represented by C, and dioxide, if we break this down, di means 2, and oxide indicates oxygen. So we know that we have 2 oxygens. This is a covalent compound, meaning that the electrons are shared and that we use prefixes when naming the compounds. So this is our chemical formula. Next, we find the molar mass of carbon dioxide. Carbon has a mass number of 12.01 grams per mole, molar mass of carbon, and oxygen has a mass number of 16. However, as we see, we have 2 atoms of oxygen, so we must multiply 16 times 2 to give us this. Now we add these 2 values together. So 16 times 2 is 32 grams per mole, and we add that to 12.01. This gives a molar mass of 44.01 grams per mole. Now we can find the number of grams. So the number of grams is the given number of moles multiplied by the molar mass. Plugging in the numbers, we have 50 moles that were given here. And we multiply that by the molar mass, which is 44.01. This yields 2,200.5 grams. So there are this many grams in 50 moles of carbon dioxide. Now, if there are 3.7 moles of the polyatomic phosphate, which is represented by PO4 and has a -3 charge, how many grams is this? Here, the chemical formula for phosphate is already given. Now, step 2 is to find the molar mass of it. So phosphorus here has a mass number of 30.97. Oxygen has a mass number of 16. However, as you might have noticed, we have 4 atoms of oxygen, which means we must multiply 16 times 4 to give us this. So this will be 64 grams per mole. 64 grams plus 30.97 grams per mole is 94.97 grams per mole, and this is the molar mass. The next step and final step is to find the number of grams. So the number of grams is the given number of moles multiplied by the molar mass. Now we plug in the numbers. The given number of moles was 3.7, and that is multiplied by the molar mass of 94.97. This gives 351.39 grams. So there are 351.39 grams in 3.7 moles of phosphate.
Thank you so much for watching this video. Remember to subscribe if you're new. And please let me know in the comments if you found this video helpful or if you have a different way that you solve these types of questions.